Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now in this particular video, it's about P3 and this is basically a test and we are looking at the solution. The test was on two particular topics. The first one is algebra, which includes a partial fraction, which includes polynomials. It includes modulus function. And what's the fourth one? That is binomial expansion. So these are the four subtopics of algebra. And algebra is a pretty big topic. The second topic is logs and indices, or logs and exponents. And there are small things in that one. So let's look at the solution of this particular paper. So now let's get started with the first question. That is sketch the graph of modulus 2x minus 3. So what I need to do is this thing. I know that this has a positive slope. That is one thing. And the second thing, the y-intercept is negative. So I can just draw a rough sketch for myself, something like this. And it's going like this. And this is negative 3. And I also need the x-intercept. So therefore y is equals to 0, 2x minus 3 equals to 0, therefore x is 3 over 2. Now keep in mind, I'm just focusing on the normal line, y is equals to 2x minus 3. Now, after drawing this, I'm flipping it. So now this thing goes like this thing goes like this, and that's how the graph is drawn. That's it. It's a reflection in the x-axis. Positive remains positive, 0 remains 0, negative becomes positive. That is the logic. Second part, that is solve this inequality. Now you people are aware of the way that I work. That is about that when I am solving a quadratic inequality, a modulus inequality, I divide it into different cases. And the case is based upon the fact that the modulus should be on the left hand side. So I've written modulus on the left hand side. The modulus is greater than this thing. Modulus is greater than this thing. So this is basically case number 2. What is case number 2? That is x modulus is greater than a or greater than or equal to a. That can be written as x less than a and x is greater than, x is lesser than negative a and x is greater than positive a. That's how we write it. So now this thing, the modulus that represents x. Everything else on the right hand side without the modulus that represents a. So therefore 2x minus 3 is greater than a, that's this one, and 2x minus 3 is lesser than negative of this side. We solve, and now what happens is that both inequalities are moving in the same direction. So we apply the true false test. We first draw a number line. We represent x is lesser than 2, that is the green line. So let me just highlight it a bit more. So x lesser than 2 is the green line. And the other one, that is the red line, x is lesser than 4 over 5. They both are pointing towards the left. So now what we do is that we choose a number somewhere over here. That is this number, 0. And we plug in the original equation, original quadratic inequality. This is also original with the sides flipped. This is also original. So when I plug in x is equals to 0, I am getting 3 is greater than negative 1. Is this statement true? The answer is yes, definitely it's true. Similarly, if I choose a number in this range between 4/5 and 2, I have chosen an easy number, that is 1. So let me choose 1 and let me plug in 1 over in the original inequality. So again, it goes in the original inequality and now we are getting 1 is greater than 2. Is that true? No, that is false. That means this particular region, this number is a representative of this region. So it's not true for this number. It's only true for this number. 0 represents this region. So therefore, what's the final answer? X is lesser than 4/5. That is the final answer. Question number 2. This is about logs. ln 1 plus x square is equals to 1 plus 2 ln x. Give your answer correct to 3 significant figures. Therefore, work in at least 4SF. If someone is working in 4SF, perfectly fine. If someone is working in 5SF, perfectly fine. Don't have to exaggerate it. ln 1 plus x square minus 2 ln x is equals to 1. According to rule of log, this becomes the power. According to the negative sign rule, let me just highlight this thing. This 2 becomes this power. This negative actually becomes the division. So 2 rules of logs are applied. Now comes the third rule. What is the third rule? No, not this thing, the other one. That is log y base a equals to x is basically another way of writing y is equals to a raised to power of x. Index to log form to index form. So ln has a base e. Log base e is written as ln, or ln is written as log base e. So now the base e raised to power of 1. We are converting this way. That is 1 plus x square over x square. Simplify, plug in the value later. You can use the calculator value. You can use the 4 decimal place value. And I'm getting 2 answers. X is equals to square root of this thing with a plus and a negative sign. X is equals to this thing we are rejecting. Why are we rejecting? Because ln does not exist for negative values. So yahan pe, my bad, I'm just going into Urdu. Ln of something does not exist. So therefore, that is why we are rejecting this thing. So now the next one, that's the only answer. Naturally, you have to accept it. You can always double check, but of course, if one answer is left, that has to be accepted. Question number 3. Now it says, express this thing in partial fractions. What needs to be seen first? So the very first thing that needs to be seen, whether it's a proper versus an improper fraction. Maximum power is 2, maximum power is 3. So yes, it is proper. Then decide on the case. This is a quadratic case. Denominator with quadratic factor. So on top of quadratic, we write a linear factor. On top of linear, we write a constant. And then we take LCM. So this multiplies with this multiplies with this. The denominator is the same, no need of writing it. So therefore, the numerator equals the numerator. The numerator equals the numerator after multiplication and after multiplication. So now this thing is done. Let me just change this color and let me write something blue over here. So that is how this thing is done. So this blue is basically the orange thing, a multiplied with x square plus 2, and the green thing, bx plus c, multiplies with this. Now there is one constant way of solving it using substitution. Of course, there is comparing coefficient also, but I'm talking about when we are solving it using substitution. The quadratic case, there is one particular methodology. That is, choose a number which will make this 0. If this becomes 0, these two will disappear. You can comfortably find a. So 1 plus 2x equals to 0. Therefore, x is negative half. So very first thing is this thing, that x is equals to negative half. We plug it in, we plug it in, we plug it in. We find the value of a. A comes out to be 1. The next step, you have to rewrite the value of a. That has to be written. And now the next step is choosing x is equals to 0. So when x is equals to 0, bx will become 0. And you will be able to find the value of c, which is 3. So now we plug in the value of c. We plug in the value of a. And now choose any other number. So choose, let x is equals to 1. So I have plugged in all the 1 over here, 1 over here, 1 over here, 1 over here, and then I find the value of b. That comes out to be 3. Comes out to be 2. So that is b. The value of a is the red one. The value of c, I think it's the blue one, and that is how this thing is obtained. Always make sure to write the answer as a fraction. Question number 4. Expand this thing in ascending powers of x up to and including the term in x square, simplifying the coefficients. Of course, that is a must. It is necessary, let me write this thing, that the first term has to be 1. 1 plus b raised to power of n, that is 1 n b power 1 over 1 factorial, and then n minus 1 b power 2 over 2 factorial, and the pattern continues. Since we are only going up till x square, that's why I did not bother writing any more terms. So first thing is that the first term has to be 1. So in this case, 2 is taking constant. When 2 is taken constant, make sure that this power of negative 2 applies to this, applies to this. So ab raised to power of m, that is a power m, b power m. So 2 raised to power of negative 2 is 1/4. This is already simplified. Now this formula is applicable over here. So now you will write the first term as 1. This is negative 2, negative 3 over 2x. I can write it like this, raised to power of 1 over 1 factorial. And then what do we have? Negative 2, negative 2, negative 1, negative 3. This thing raised to power of 2 divided by 2 factorial can be written as 1 over 2 factorial. We simplify. Don't forget the 1/4 on the outside. Open up the bracket. That is the answer. Then it asks a question for 1 mark. That is, state the set of values of x for which the expansion is valid. So 1 plus b raised to power of n. For this question to be answered, because we don't study it further, we say that b modulus should be less than 1. So what is b over here? This is in place of b. This modulus is less than 1. 3 over 2 is taken outside. Modulus x is less than 1. So therefore x modulus, we multiply it. So x modulus is lesser than 2/3. We just do this much and that's more than enough. Question number 5. Now it says use the substitution, solve the equation, give your answer correct to 3SF. So u is 3 power x. Now we know that a power mn can be written as a power m raised to power of n or a power n raised to power of m. Bottom line is that m and n are multiplying. So m inside, n outside, or n inside, m outside. So basically 3 raised to power of 2x can be written as 3 power x whole square or 3 power x raised to power of 2. I think I've written it twice. So this is 3 power 2 raised to power of x. Of course, it can also be written as 3 power x plus x. So I have chosen this format. Got it? So basically that is 3 power x raised to power of 2. 3 power 3x is 3 power x raised to power of 3. So now 3 power x is replaced with u. This becomes u square. This becomes u cube. Transfer all terms on one side. And then what is happening? We have taken u common and we are left with the quadratic. Now since this is P3, you are using the quadratic formula. So when we use the quadratic formula, we are getting 2 values. We also have the value of 0. So basically, u is 0, u is negative, u is positive. But what is u? U is 3 power x. 3 raised to any power can never be 0. No solution. Remember the graph? If you don't remember it, let me make you remember, because logic has to be known. So now if I draw a graph of a power function, this is y is equals to a raised to power of x. A is a positive base. A raised to power of 0 is 1. There is a horizontal asymptote, which is the x-axis. What's the equation of x-axis? Y is equals to 0. That is the y-axis. So now it gets very close to this, but does not touch it. So therefore, a positive base raised to any power can never be 0. A positive base raised to any power cannot be negative. That is why we have no solution over here. Got the idea? So now 3 power x is 1.6180. And then over here, we take LG or ln of both sides. X comes out to be 0.438. That is the answer over here. So pretty nice question. Question number 6. What is this all about? This is linear law. We have ln y, we have x, we have 2 points. They are related by this equation. A and k are constants. Find the value of a and k correct to 2 decimal places. Work in 3dp. Now the very first thing that needs to be done, that is coordinate geometry. We find gradient. So gradient is coming out to be positive 0.4011. Of course, it has a positive slope. We plug in y is equals to mx plus c. Plug in any point. We find the value of c. That's right over here. That is step number 1. What is step number 2? So this is step number 2. That is application of logarithm. Take natural log of both sides. So when we take natural log of both sides, ln of y square is ln of this thing. These are multiplying, so there is a positive sign. Then what is happening? This power is coming down over here. ln e is 1. Get rid of this 2. This power also comes down because of log. So now we have this thing that is in the form y is equals to mx plus c. ln y is the y, x is the x. Double check. ln y is the y-axis, x is the x-axis. So now the coefficient of x is the gradient and the constant all alone is the y-intercept. Coefficient of x is the gradient. Gradient is 0.4011. Therefore, k comes out to be this much, correct to 2 dp. Half ln a, that is the y-intercept. That is the y-intercept. First make ln a the subject, then make a the subject in terms of e, then use a calculator and simplify. That is how you get this answer. So now in this particular paper, we are seeing logs, equation, we have seen linear law, we have seen binomial, we have seen partial fraction, we have seen another ln question, we have seen modulus equation, we have seen modulus graph. I mean, it's one comprehensive paper. Not difficult, but comprehensive, definitely, no doubt about that. That is the whole purpose. So now this one is on polynomials. So the polynomial is denoted by px. It is given that x plus 1 is a factor of px. If x plus 1 is a factor of px, let me highlight it. That means if I plug in -1 in px, it should equal to 0. So this is an application of factor theorem. Similarly, if it's divided by 2x plus 1, therefore x is -half. Now the remainder is not 0 because this is not divisible. So the remainder is 1, that is 1 over here. So this is an application of factor theorem. And the other one is an application of remainder theorem. So make your concepts very, very clear. So now that is remainder theorem. And this one over here, that is the factor theorem. Now the rest is all basic O-level arithmetic that you have been using all your life. That is one equation. That is the other equation. We solve it simultaneously. So that is the red equation, b plus 9. That is also equals to a, and a equals to 2b plus 12. We solve these two. We find the value of b, that is -3. We find the value of a, that is +6. Now when a and b have these values, factorize fx completely. I have plugged in the value of a, I have plugged in the value of b. That is how px looks right now. X plus 1 is a factor. So therefore, take this cubic, divide by a linear factor, we get a quadratic quotient. Take the highest power, divide, and then multiply like this with every term. Change the sign and add. Repeat the same process until you get a 0. So px is basically this into this. Is this factorizable? Yes, it's factorizable. Are they asking us to factorize? Yes, they are only asking us to factorize, and that is where we stop. Let's say one thing. So let me draw a box over here, and the box is not good. If they would have said that solve the equation. So let me just add a page over here. Solve the equation px equals to 0. So we would continue from here. We would write x plus 1, 2x minus 1, 4x plus 1 equals to 0. Therefore, x is -1. Therefore, x is +half. Therefore, x is -1/4. These will be the roots or solution of equation. Technically, this is the x-intercept. So these are the same terminology that we have used in P1. So basically we are done and dusted with this particular P3 paper, which was about algebra and which was about logs. See you in the next class.